Hello everyone, this is Jamie here. Welcome to another session of Vistex for Services. In this session, I'll be taking you through the amazing process of working and updating 3ds Max files while having live links from external files such as Sketchup, Autocad, Revit, Rhino and Archicad. For the purpose of this exercise, we'll be using external Sketchup model to directly link to our 3ds Max file. As mentioned earlier, the same can be done with files coming from applications such as Autocad, Revit, Rhino and Archicad. This is a SketchUp model of a building. We'll be linking to our 3ds Max file to shade, texture and render while the SketchUp files is live and being updated externally. In order to bridge between the two files and execute the above mentioned functionalities, we need to use an amazing script called Mirza Link Manager. To find and download the script, simply Google Mirza Link Manager and go to his website. I'll leave the link in the descriptions. In their website, you can simply click here to download or buy it. After downloading the script, you can drag and drop it into the viewport to install it and access it from the toolbar. Or simply click on the scripting toolbar and choose to run script. Load and open the script. Each dialog should appear. Enable the terms and condition options and click to install the script. The script is now installed. Before we open the script, it's worth pointing out that, as you can see, the landscape is already built in 3ds Max. I personally prefer to create the landscape in 3ds Max because of proxy files, rel clone and forest pack, which are amazing to quickly create landscape realistically. However, feel free to use any other approach you find more appropriate. Before we open the script, let's create a toolbar button for it. To do so, click on the Customize toolbar and choose the Customize User Interface option. On this list, choose the Mirza Tools command, followed by clicking on a new button, and type its name. Once the new button is created, drag the Mirza action into the new button, followed by simply placing it on a toolbar by snapping against it. Click on the script button to open this dialog. Most of these functions are quite self-explanatory really. The function to update updates linked files. The add only function adds files. The duplicate function duplicates linked files. Under import from, you have the option to bring in files from Archicad. Under each option, there's information on how to export files from each application. Next, we have the option to bring files from Sketchup, Rhino, Revit and Autocad. This import button allows you to click and choose the file to import. Underneath, we have the default options to auto-weld imported files, auto-edges and auto-smooth, and to refresh screen when imported files are updating. As mentioned earlier, for the purpose of this exercise, we are going to work with files from Sketchup, but users can also import files from all these other applications seen here. The imported meshes can be organized by materials or by layers. By default, it's set to be organized by materials. To export the building from the SketchUp model, simply go to the file, press Ctrl+A on your keyboard to select the entire scene, followed by clicking on the file button and choosing to export 3D model. In the Save As type, choose the object file from the list. If unsure, simply go back to the 3ds Max file to check the information detailing how to export from each application. Before exporting, click on the options toggles first. In each dialog, enable the export texture maps and leave these other options unchecked. In a scale group, always uncheck the option to swap YZ coordinates, otherwise your imported model will be flipped upside down. Finally, choose the meter unit system and click OK to export the mesh. Back in 3ds Max, click on the Import Model button and choose the object model from SketchUp. As you can see, the file should begin loading up. Depending on the complexity of your model, it may take seconds or longer to import. Once the file is fully imported, this dialog box should be prompted. Click OK to accept it. Here, you can see the imported file linked to the scene. If your 3D model happens to be slightly off from where it should have been, simply move and place it on its correct location. Next, click on the Update Selected Link button and choose the model as before. As you can see, even though the file is currently linked, the model was updated without resetting its location in 3ds Max. In SketchUp, the model is still on its original location, which is amazing. The same also applies to textures and shaders. However, if you were to delete parts of the model in SketchUp, then it would have been updated in 3ds Max. The next step is to begin creating and assigning shaders with textures to this model. Select one of the wall panels and click the button to isolate it. Next, open the material editor by clicking on this button. Select this wood material slot and assign it to the wall panel by clicking on the Assign button. Click on the diffuse toggle and enable the Show Shaded Material in the viewport. In the modifier panel, apply the UVW modifier and the Mapping Mode to Box. Minimize the Material Editor dialog and exit the isolation mode. Click on the Material Editor and select the glass panels in the viewport. In the Material Editor, select the glass material slots and assign it to the selected object. Next, let's select the lower panels in the viewport. Select this material slot and assign it to it. Following that, let's select the roof panel in the viewport and assign this metallic material to it. Next, let's select our Sketchup link and click the Update Link button. As you can see, the materials, textures and the full model position have all been updated accordingly, which is amazing. Another example will be to go to the Sketchup file, delete part of the model, press Ctrl+A on your keyboard to select the entire model, click on the File button and choose to export the 3D model again. Choose to confirm and replace the file name. Back in 3ds Max, select the Sketchup model link and click to update selected link. Select the object file in question and open it. As you can see, the model was updated as expected. After applying all materials and textures, the final scene should look similar to this one. As mentioned earlier, I personally prefer to create landscape in 3ds Max because of proxy files, Railcon and Forest Pack, which are amazing to quickly create landscapes realistically. However, if you prefer to build a list of external links from applications such as Revit, Autocad, Archicad, Rhino or Sketchup, simply enable the Create function and click the Import Model button. As you can see, users can build a big list of external files if desired. Next, let's do a quick test render to see what the scene is looking like. Click on the Render Setup button to open its dialog. Let's check some of its default parameters first by going through its tabs. And click Render. This is a 3ds Max LUT file I've used in vray frame buffer to make the raw render look more appealing. Also, ensure the option to convert log space before applying LUT is disabled. In order to apply it, I first select on the Show Correction Control button and open its settings. All these other correction controls will close apart from the LUT, followed by enabling and loading it from the Load toggle. If you uncheck it, this is what the raw render will look like. When enabled, with the LUT loaded, it looks like this. The word LUT stands for Lookup Table. By clicking on the Load toggle, you can locate and load a specific LUT file. This specific LUT file came from a website called 3D Collective. Unfortunately, LUT files are for display purposes only and are not factored in when saved. In order to save the current render with the LUT file applied, we need to use Chaos Group script called LUT Explorer. To apply this script, simply click on the scripting button and choose to run script. Select an open LUT Explorer script from Chaos Group. This toggle allows users to locate and pick the LUT file. This second folder allows users to set the location, file name and extension. By default, the file extension is set to PNG. Let's change it to JPEG file type and name it accordingly. Followed by clicking the Save Variations button. After the file is saved, the script automatically deselects the LUT file from the frame buffer. To view the save render with LUT applied, simply go to the rendering toolbar and choose to view image. As you can see, The saved image looks exactly like the render with the LUT applied. Also, here you can see how the file was saved. The file name first, followed by the LUT file name added in front. To send this file to render, in a Commons tab, let's set the render output size to 3500 pixels by 1850 pixels. As you can see, the image aspect function is padlocked, so the width and height values are linked to one another. Under vray tab, expand the global switches rollout parameters, and the frame buffer. Under frame buffer rollout parameters, enable the vray raw image file function. Click on this toggle to open it. Type in the file name and enable the EXR option, deep EXR, and the delimited frame number. The vray image file type is a very powerful raw file format that allows users to reload it into the frame buffer and save it out again in any file format desired. When enabled, it saves the data of each rendered bucket, so if per chance the render crashes abruptly, the last bucket will be saved. Click the Save toggle. Next, enable the separate raw image file function and click on this toggle to open it. Name the file accordingly and choose the TIFF file format. Click on the Save toggle. In the TIFF image control dialog, enable the 16-bit color, no compression and 300 dots per inch, followed by clicking OK. Under the image sampler rollout parameters, the minimum shading rate is set to 64. A high value such as this improves the render quality without affecting the rendering time. When test rendering, some users prefer the progressive type, which is fine. However, for final high resolution renders, you should use bucket rendering type, especially when it comes to using strip renders and other key functionalities. Under image filter, choose the area type. I personally prefer this image filter type. However, feel free to choose from a list of other image filters seen here. Under bucket image sampler rollout parameters, I often set the minimum subdivision to 1 and the maximum to 100 to be coherent with the universal workflow settings. In the noise threshold, let's set it to 0.007. Expand the global DMC rollout parameters and set its noise threshold value to 0.003 or 0.004. This noise threshold value from bucket image sampler rollout should always be higher than this global DMC noise threshold value here, otherwise the renders might take a bit longer than usual. These two noise threshold values are dependent of one another. These values have always worked well for me. However, feel free to use other values you are more comfortable with. Expand the color mapping rollout parameters. I'm currently using exponential color mapping type because it helps to balance overexposed areas in a render and makes your raw render more realistic. However, feel free to use other color mapping types. Also, the bright multiplier was reduced to 0.3 for this specific scene. Otherwise, I would normally keep it at 1.0. Under mode, I'm using the color and gamma type. In the GI tab, the primary engine is set to radiance map and the secondary engine is set to light cache. Enable the ambient occlusion function. I normally set the ambient occlusion value to 0.7, the radius to 300 mm and the subdivisions to 24. These values only affect indirectly lit areas. Also, these values work well. However, feel free to use values that you're more comfortable with. Under the radiance map rollout parameters, keep the current preset as low. External daylight shots don't usually require high settings. Under light cache rollout parameters, leave the default parameters as they currently are. In a settings tab, I normally keep the dynamic memory limit to 0 so vray can use as much memory as required. In a render elements tab, enable the render elements previously added. Check the remaining settings and click to render. In a completely new 3ds Max scene, we can open the render setup dialog. In a vray tab, click on the Show vray frame buffer button to open its dialog. Next, click on the Load Image File button to load up the vray image file previously saved. This is what a vray image file should look like. They are often large in size because of the data stored in them. Click to open it. Depending on the file size, it may take a while to open. As you can see, vray frame buffer resizes its frame dimensions automatically to fit the incoming file. There are times when this automatic resizing doesn't occur. This often happens when the original vray image file is saved in a different version of vray. In such cases, users should simply type in the correct output size over the incoming file here prior to loading the vray image file format. Here, you can see all the render elements previously stored in a vray image file. Users can turn off the sRGB button if desired, followed by clicking and holding this button and choosing to save all image channels to separate files. Choose the file format to save as. I often choose EXR or TIFF file format. Name the file and click to save. In the TIFF image control dialog, enable the 16-bit color option with no compression and 300 dots per inch. The file will save with all the render elements. To view the save file, simply click on the rendering toolbar and choose to view image file. The saved image looks slightly brighter than the one in the vray frame buffer. To rectify this, let's resave the files again in a separate folder. Enable the override option and set it to 1.0, followed by saving it again. Open the newly saved image in 3ds Max. As you can see, the gamma of the newly saved image now matches with the one in the frame buffer. Next, let's enable and load the LUT file previously used. Here, we can preview the render and the LUT with sRGB button turned on and off. Following that, as previously done, let's run the LUT Explorer script and save multiple versions with sRGB on and off. To make the renders more realistic, let's open them in Photoshop. I'm currently using Photoshop CC 2018. This render is the version with sRGB applied and the gamma set to 2.2. In a Layers tab, right-click and choose to duplicate layer. While the duplicated layer is still selected, right-click and choose to convert Smart Object. Smart Objects are quite useful to retain the parameters of filters and the original quality of an image when scaling up and down. Next, click on the Filters toolbar and choose the Camera Raw filter from the list. In each dialog, increase the dehaze function to add more detail and contrast to the image. Let's also increase the clarity functions to bring up more details and shadows to the image. And reduce blacks function to add a bit more contrast. Let's also adjust the whites function to make the overall image more realistic. Finally, let's adjust the shadows function to make the overall image pop and click OK to accept the new parameters. To mask out parts of this Camera Raw filter effect, let's create a layer mask by clicking on this button here. Next, enable the brush tool. Following that, switch the background color to black by clicking on the switch button here, or by simply pressing X on your keyboard to switch between the two background colors. Black or dark colors omit pixels when brushing with the layer mask enabled, and white or bright colors do the opposite. Also, note that the opacity is set to 36%. This is to ensure the brush pressure is low. While the background color is black and the layer mask is enabled, begin brushing the pixels of the specific areas to gradually omit them. Reduce the opacity value to minimize the brush effect on pixels when brushing. Zoom in and out of the document to check the overall changes. The render is looking a lot more appealing with the latest changes. Smart Object Layers gives users the unique ability to edit parameters by simply double-clicking on the Camera Raw filter and tweaking it when necessary. Let's minimize the document behind. Finally, let's create the Chromatic Aberration effect. This effect is often seen in real photos and makes most computer-generated images look more realistic as a result. To apply it, simply right-click on the edge of the document and choose to duplicate. Right-click on any layer and choose to flatten the image. On the bottom left part of the document, type in 100 to zoom 100% into the document. Next, go to the Channels tab and select the red channel. Enable the Move tool and nudge it up once by pressing the arrow on your keyboard. Select the green channel and nudge it down once by pressing the arrow on your keyboard. Select the blue channel and nudge it to the right once by pressing the arrow on your keyboard. Following that, select the RGB channel to view the final Chromatic Aberration effect. Go to the Layers tab and select the main document behind. Select the Chromatic Aberration document again and choose to duplicate the layer as previously done. In a Duplicate Layer dialog, choose the destination document to be the main PSD file and rename the incoming layer as Chromatic Aberration. Select the main document As you can see, this is the new chromatic aberration layer. As you zoom in, the chromatic aberration seems a bit too prominent. To reduce its prominence slightly, let's click on the layer blending mode and choose the darken type from the list. Reduce its opacity to about 49% to make it even less prominent and more realistic. Add a new layer mask to the chromatic aberration layer and brush away the vignetting effect slightly. Use some of the techniques described earlier. Finally, choose to save the final image as a TIFF file format, and check the option to save layers and click to save. Also, save another version as a JPEG for printing, and as a Photoshop file format to be able to edit layers if required. For more information about Mirza Link Manager, simply check the link descriptions. This concludes our tutorial. I really hope you find it useful, like and share it, and I hope to see you on my next one.